Welcome to EDU World Space.
This is chapter 21, problem number 30. We're asked the strength of the electric field acting on a proton if this proton is experiencing an acceleration that is 1.8 billion times the gravitational acceleration g. So again, we're dealing with the proton, right? So in order for us to be able to accelerate a proton, we need to provide it this energy to this acceleration, right? M times A, M being the mass of a proton. So this force has to come from somewhere. In this case, it's coming from the electric field, right? So then this Q times E, which gives us the electric force, this force is due to the electric field, and that's what we're trying to calculate. So then MP, the mass of a proton times the acceleration of the proton, equals to the charge of a proton times the electric field in which it's embedded in. So if we divide both sides by the charge of an electron, then we can get to the strength of the electric field. So it's going to be the mass of a proton times the acceleration divided by Q. Well, let's remember the mass of a proton is something you can look up, 1.67 times 10 to the power negative 27 kilograms. And the charge of a proton is what we call the positive E, which is 1.602 times 10 to the power negative 19 coulombs. So then when we plug everything in here, 1.67 times 10 to the power negative 27 kilograms times the acceleration being 1.8 million G's. G being 9.81 meter per second square, right? And then in the denominator we have 1.602 times 10 to the power negative 19 coulombs. From here, the strength of the electric field turns out to be 0.18 newtons per coulomb.